Hello everyone, welcome to my channel Chemistry Lovers. Today I have talked about the nucleophilic substitution reaction. So first of all, what is nucleophilic substitution reaction? So nucleophilic substitution reaction is such a type of reaction where an incoming nucleophile attacks upon the alkyl group which directly attached with the halogen atoms. As a result, the halogen atom leave from the alkyl group in the form of halide ion and the incoming nucleophile take the place of it. So this is the basic definition of it, that what is nucleophilic substitution reaction. Now this nucleophilic substitution reaction can be classified into two categories, Sn1 and Sn2. You know Sn1, which is also known unimolecular nucleophilic substitution, and Sn2 bimolecular. Sn1, if we talk about Sn1 reaction, Sn1, which is an example of nucleophilic substitution reaction. Why it is called unimolecular? Because the rate of this reaction only depends upon the concentration of the substrate. Substrate means reactant or alkyl halide, which is the main reactant of this kind of reaction. Hence, it is known as unimolecular nucleophilic substitution. Unimolecular means it depends upon the concentration of alkyl halide. Hence, it is known as unimolecular. It also takes place in presence of weak base like NaOH or KOH, in presence of water, which is a polar solvent. Here polar solvent is required in this kind of reaction, especially for Sn1. Non-polar solvent is not suitable for this in this case, and it will be take place in two steps. First, the halogen atom removes in the form of halide ion from the alkyl group, and next then incoming nucleophile attacks on the alkyl group, which becomes partially positive charge. I am not talking about the mechanism of it. I am only talking about the basic concept or information about this type of reaction. If you are interested to know the mechanism of Sn1 or Sn2, then I will bring this topic on next video. Okay, so these are all about Sn1 reaction. You can see that polar solvent is required in this case, and the nucleophile may be weak or strong, it doesn't matter, but the nucleophile is required in this kind of reaction. Now I am talking about Sn2 reaction. Sn2 reaction is also another example of nucleophilic substitution reaction. It's called bimolecular nucleophilic substitution. Here it is. Bimolecular means its rate of this type of reaction depends on the both concentration of alkyl halide and incoming nucleophile, while the Sn1 becomes unimolecular as the rate of it depends only on the alkyl halide. But here the rate of Sn2 depends upon both the active mass of nucleophile and alkyl halide. Hence it is known as Sn2 or bimolecular nucleophilic substitution. So there are some differences can be observed between these two kind of reaction, though they are both belong to nucleophilic substitution reaction. Also, the solvent is non-polar. In this case, the solvent which is required becomes non-polar, and the nucleophile should be strong in order to take place the Sn2 reaction, like OR minus or alkoxide, and you know OCH3, OC2H5. These are very strong base which can participate in this kind of reaction, and here the transition state developed as an intermediate during this type of reaction. You can see here. So the most common thing is in both cases the reagent is alkyl halide, and from this the product is different. For Sn1 the product is alcohol, but for Sn2 the product is ether. So the product is different in both cases, but the reactant becomes same, alkyl halide, and the nucleophile also different here. Another important thing I have to mention that Sn1 reaction or the rate of Sn1 reaction directly proportional to the stability of carbocation. Here I have not written this thing, I have forgotten, and hence I have told it in the video. So the rate of Sn1 reaction directly proportional or depends upon the stability of carbocation. That is, the carbocation becomes the intermediate of Sn1, while for Sn2 the intermediate is a transition state. Here you can see that the incoming nucleophile OR minus attack on the alkyl group R, which can be methyl, ethyl. I am generally written here in this way. OR minus will attack on the alkyl group, hence the bond formation here, and here the halogen atom breaks it and removes as a halide ion, and in this way finally product here can be obtained this way. R dash may be the alkyl group may or may not be same here, because the alkyl group may be different in this case, and halogen also different in this case. So here now in short I am also showing you the difference between these two type of reaction. You can see here the difference is, first, nature of nucleophile. For Sn1 it is weak nucleophile required, while for Sn2 it's strong nucleophile required. Next point comes, that is solvent. For Sn1 polar solvent required like water, but for Sn2 non-polar solvent required like alcohol, acetone, etc. Intermediate is carbocation for Sn1, but Sn2 there is a transition state developed. Rate of reaction for Sn1 depends only on the alkyl halide or haloalkane, which is reagent here, substrate, but for Sn2 it depends upon alkyl halide and incoming nucleophile. There are two steps involved for Sn1 but one step for Sn2. Okay, and the thing which is I have already mentioned, that the alkyl group should be bulky in case of Sn1, because there is a carbocation formed as an intermediate during this kind of reaction, but for Sn2 the alkyl group should be less bulky because there is only one step involved there, and hence less bulkier alkyl group is preferred for Sn2. And last difference is attack of nucleophile for Sn1 on both front and rear side, but for Sn2 only at rear side. So these are some difference you can see, through which you can clearly understand the major difference between these two kind of reaction, though they are belong to the nucleophilic substitution reaction. So this is all over it. If you interested to show the mechanism, then I will bring this at upcoming video. So today, if you like this video, then please comment, like and share, and don't forget to press the bell icon so that I will come to know that you are watching my video properly. So thank you.